Hello, and in this video we're going to be covering lesson 2.2, which is solving absolute value equations, and 2.3, which is solving absolute value inequalities. Alright, so looking at the information back from 2.1, we learned about the absolute value, and remember, it was called the optimistic function because it takes anything negative and makes it positive. So here we have positive 5. And if you already have something positive inside the absolute value, it keeps it positive. So this is still positive 3. Now, question number 2. Solve and graph the absolute value of x is equal to 5. So what this is asking right here is, what am I going to plug in for x? What am I going to take the absolute value of so that it gives me positive 5? Well, look at the previous two problems. Here I have positive 3. Here I have positive 5. So what did I plug in for x here? X equals negative 5. Now, is that my only answer? Is there something else that I can plug in besides negative 5 so that I get 5? Well, a lot of you were able to guess this. The other answer is x equals 5. So notice I can plug in negative 5 or positive 5 in for x, and that's going to give me 5. Now, is there any other possible number that I can plug in for x so that I get a positive 5 out of this? So I did ask my students this, and they gave me, some of them said yes, there is, but they couldn't give me a number. And so what we concluded was that there are only two solutions possible. At most only two solutions possible where we can have a positive 5. And so when we graph these are basically points on a number line. And here are my two solutions right there. Alright. So here we go into taking an absolute value equation here. Remember when we went over the transformations and taking a look at how the graph looks like? Well, in this case, what we're doing here is we're solving it algebraically and trying to figure out where are our two solutions going to be on our number line. So this is what we're doing, solving the absolute value function. Now we're going all the way back to reverse Pemdas in order to guide us on how to solve this absolute value function. So remember, our first level was addition or subtraction. Second level was multiplication or division. Third level was exponents, and finally the last level was parentheses. Now, since we're talking about absolute value functions, I'm going to include, along with the parentheses, is the absolute value. So remember, the absolute value are these vertical lines right here. So we're going to treat these vertical lines inside the vertical lines as if they were parentheses. So in our last level, we have either parentheses or the absolute value. Alright. So, following reverse Pemdas, what I want to do is look to see if I have addition or subtraction. Well, you may say I have subtraction here, but remember, we leave anything inside the absolute value last. So this is last. That means that my other operation that I have here is minus 4, so I have a subtraction And what is the opposite of subtracting 4? Well, that's going to be to add 4. So whatever I do to one side, I have to do to the other. So minus 4 plus 4, that goes away. All I have is 2 times the absolute value of 5 is equal to 2 plus 4. Well, that is going to be 6. Okay. Do we have any addition? Nope. We're done with that. Let's go ahead to the second level, multiplication or division. Now, this 2 right here, right in front of the absolute value, it's implied that I'm multiplying by 2. So we do have multiplication. And what is the opposite of multiplying by 2? Well, that is to divide by 2. So 2 over 2 becomes 1. That's basically the absolute value of x minus 5 is equal to 6 divided by 2, which is 3. Now, this is what I want to do. Take a look at this. Here, the absolute value I have right here. And what happened to this 2 and this negative 4? Well, I got rid of them. I did the inverse operations, moved it to the other side, and I'm left with 3 on this side. And so, is there anything outside the absolute value now? Is there anything outside these vertical lines besides the equal sign of the 3? On the left side specifically. Anything outside the absolute value? No. I got rid of this 2, this negative 4, so what I did is I isolated the absolute value expression. So that's what I did. I isolated the absolute value expression. I got rid of that 2, that negative 4, now it's all by itself. It's isolated. That means what I can do now is I can go to step 2, and step 2 is basically to write 2 equations and solve for x. Now there's something very important here. What do I mean by write 2 equations? Well, this is what I mean. Let me go ahead and write it out and then explain to you. So x minus 5 equals 3, or x minus 5 equals negative 3. Those are my 2 equations. Now, how did I get those 2 equations? First of all, do you see the vertical lines anymore? No, they disappeared. So when you go from the absolute value, once it's isolated, and you go to 2 equations, you get rid of the absolute value. It's no longer there. Now, what we had inside the absolute value is going to stay the same. So notice here, x minus 5 and x minus 5, it stays exactly the same. Nothing changes. The sign stays the same. I just got rid of the absolute value. That's it. Now, the 3 is what is going to change. So here, well, it didn't change. It just stayed positive. But when I take a look at the other equation, the sign changes. So I went from positive 3 to negative 3. So again, to complete step 2, you take anything inside the absolute value and it stays the same. X minus 5, x minus 5. Nothing changes. Don't change the sign. Don't touch it. On the other side of the equal sign, that is what is going to change. So basically you go from positive 3 to negative 3. So there we go. We wrote 2 equations, and now remember, once we have our 2 equations, remember, going back here, our absolute value is going to have 2 solutions, at most 2 solutions. And so if we solved each of these equations, we're going to see that we are going to get 2 solutions. And so these are simple equations we can solve. We can just basically add 5 to both sides. And so x is equal to 5 plus 3, which is 8. And here on the other equation, again, we add 5 to both sides, but this time we have that negative 3, so x equals to negative 3 plus 5, which is 2. Those are my two solutions. And last thing I want to do is just graph them on the number line. So here 2 would be right here, and then 8 would be right there. That's it. You just have to follow those 2 steps. Isolate the absolute value. That means get rid of everything outside of those vertical lines. Don't focus on the other side of the equal sign. You're just focusing on the side that the absolute value is on. So you're focusing on the side that the absolute value is on. Get rid of that 2. Get rid of that negative 4. Move it to the other side by using reverse Pemdas. And once you have your absolute value expression isolated, that's when you go to step 2 and write 2 equations. Now, a lot of my students make this mistake. When they write the 2 equations, they include the absolute value. Step 2 is where you get rid of the absolute value. So you go from one absolute value equation into 2 equations without those vertical lines. And just remember, this stays the same inside the absolute value. This is where the sign changes. Positive 3, negative 3. And then once you have your 2 solutions, you graph them on the number line. Alright. So we concluded that the most number of solutions you can have is 2 for an absolute value equation. So let's take a look at this paragraph. You have seen that the absolute value equations have 2 solutions when the isolated value expression is equal to a positive number. When the absolute value is equal to 0, there is a single solution because the 0 is its own opposite. When the absolute value expression is equal to a negative number, there is no solution because the absolute value is never negative. So if we look back to our warm-up, what if I were to ask you this? Instead of having a positive 5, where the solutions for this one were x equals 5 and negative 5. If I change that 5 into a negative, is it possible for me to put in something for the absolute value that gives me a negative number 5? Well, if I plug in absolute value negative 5, well, that gives me positive 5. If I plug in the absolute value of 5, that gives me still a positive 5. What did we say about the absolute value function? It takes anything negative and turns it into positive. And if it's already positive, it keeps it positive. So does this have any solutions? The answer is no. There are no solutions. It's impossible. You can't make this function have a negative answer when the absolute value is isolated. So nope, you can't do it. And what it was saying here is that so we looked at the example when we had the absolute value equal to 5, but now it's asking you, what if we have the absolute value of 0? How many solutions can I put in here? Well, I can put the absolute value of 0 equals 0, and notice, is there any other number that I can put in there? Well, you may be tempted to say negative 0, but negative 0 does not exist. It's only 0. And so notice, whenever you have something, the absolute value equal to 0, the number of solutions you're going to have, in this case, we just have one solution. So let's go ahead, and there's the answer, by the way. Let's go ahead and take a look at two different examples here where we see 1 or 0 solutions. So let's take a look at this first one again. Remember, along with parentheses, we're also including absolute value. So going through reverse Pemdas, the first thing we wanted to do is isolate the absolute value. Value expression. So here it is. Everything on the side, on this side, we want to get rid of everything outside the absolute value, everything outside those vertical lines. So we have to get rid of that -5 and +2 in order to complete step 1. So we're going to use reverse Pemdas for that. We have addition or subtraction. Here we have +2. The opposite, the inverse, is to subtract 2 on both sides. Whatever you do to one side, you have to do to the other. And so we have the absolute -5 times the absolute value of x plus 1. That goes away, and so we have 12 minus 2, which is 10. So we're done with addition or subtraction. Do we have any multiplication or division? Yes. Here, again, if we have a number in front of the absolute value, it's basically saying that we're multiplying that number by the absolute value. So -5. What is the opposite of multiplying by -5? Well, it's to divide by -5. Whatever you do to one side, you have to do to the other of the equal sign. So that goes away, that becomes 1. So we have x plus 1. The absolute value of x plus 1 is equal to 10 divided by -5. That is -2. So the absolute value is isolated. This is done. Now you may be tempted to do this. Go straight into step 2, which is good that you remember step 2, which is to write two equations and solve for x. But notice, what did we say? Whenever the absolute value is isolated, there's nothing outside of it on that side of the equal sign. If we have a negative number here, we have a problem. And what we said was, the problem is that whenever you have the absolute value isolated here, and you have a negative number, we said that there are no solutions. It's not possible to take the absolute value of something and get a negative number. Which is exactly what we have here. Now you have to remember, the absolute value has to be isolated in order to know if you have 0 solutions. Since we already did that, and we have a -2, then this is going to have no solutions. And so if you're aware of this, then you can stop right there. You don't have to go to step 2. And that's our final answer. No solutions, because this is negative and because the absolute value is isolated. Alright. Let's take a look. Is that my only example? Okay. Well, let's go ahead and give number 6 a try. So, again, let's use reverse Pemdas. And don't forget to include absolute value with parentheses. So, again, first step is to isolate the absolute value. We want to get rid of that 9, we want to get rid of that 7, and move it to the other side. We're going to do that using reverse Pemdas. So here, first level, addition or subtraction. Well, here I see that I have addition. So the opposite of adding 7, we're going to subtract 7 on both sides. So we're left with 9 times the absolute value of 4 over 3x minus 2 is equal to 7 minus 7. Well, that's going to be 0. Alright, so we're not done with step 1 yet. We have to take care of that 9 outside the absolute value, and that is going to be multiplication. So we're multiplying by 9. What is the opposite of multiplying by 9? The inverse is to divide by 9 on both sides. Whatever you do to one side, you must do to the other. So we have 4 over 3 x minus 2, 0 over 9. That's basically 0. Okay. So notice we don't have a negative number here, so that means that we have to go to step 2. So step 1 is done. We isolated, we got rid of that 9, that 7. So now we isolated the absolute value expression. Step 1 is done. Step 2 is to write 2 equations. Remember, whatever's whenever you write 2 equations, the absolute value goes away, and whatever we have inside the absolute value stays the same. Don't change anything about the sign, and this is where the sign changes. So here we have equals 0, and my second equation, we change the sign, negative 0. But wait a minute, is there something wrong here? Okay, we have 0. Okay, that seems normal. What about this? Negative 0. What do we say about negative 0? Negative 0 doesn't exist. So going all the way back to this right here, we said that anytime you isolate the absolute value and you have it equal to 0, how many solutions did we say it's going to have? It's just going to have one solution, which is exactly the same situation we have here. We can't have this equation because we can't set it equal to negative 0. And so in this case, we just have one equation, which means we're going to have one solution. So we have to find that solution, and let's go ahead and solve. So your work is cut in half. You just have to solve for one equation. So let's go ahead and solve this. So again, you want to restart reverse Pemdas. So we want to add 2 to both sides first. Equals 0 plus 2 is basically 2. Now, a lot of you take this fraction as a single number, and since we're taking 4 over 3 and multiplying by x, we say that we can also divide. The opposite of multiplying by 4 over 3 is to divide by 4 over 3, and so we get that x is equal to 2 over 4 over 3. And then you have to rely on your calculator to find this. What you could also do is that since here we're basically multiplying by 4, but here we're dividing by 1 over 3, we can just take the inverse of that, which is to multiply by 3 and divide by 4. So we can multiply both sides by 3 over 4, and that is still going to give us the same answer. So this just basically becomes 1, and what we have left here is basically 2 times 3, which is 6 over 4. And you're going to get the same thing when you plug this into your calculator. It's going to be 6 over 4, which simplifies to 3 over 2, and 3 over 2 is equal to 1.5. So x equals 1.5. And that is our one solution right there. Alright, so we took a look at two examples where one has just one solution like this one, and the other one has no solutions. Alright, let's go ahead and move on to lesson 3-2. Lesson 3-2 is about solving absolute value inequalities. So we have to remind ourselves about inequalities. Okay, so let's go ahead and write this out. Remember, whenever you have this symbol right here, this symbol is called less than, and this symbol is called greater than. Now, when you have that line underneath it, it's still called less than, but we also add less than or equal to. That's what that line means, equal or equal to. So here we have greater than or equal to. Let me move that up. Less than or equal to. Now, because we are going to graph some solutions on a number line, it's very important to note that whenever you have less than or greater than, you're going to be using an open circle. And when you have less than or equal to or greater than or equal to, you're going to be using a closed circle. Now this will make sense once we start solving for inequalities. Now, we're going to look at inequalities, and this may not make sense to you, but let's go ahead and write this. This is similar to the domain, so you have seen something like this, where the smallest number goes on the left and the largest number goes on the right. So we're still going to write our inequalities are like this. And there's something very important. This setup is going to let us know that whenever we have less than or equal to, we are going to always shade on the inside, and when we have greater than or equal to, we're always going to shade on the outside. Now, this is a lot of information right now, and you will know exactly what we mean by this shade inside or outside once we start graphing our solutions. So we'll come back to this. Okay. Now, because we have these symbols right here, we no longer call them equations, we call them inequalities. And actually, the very first step to solving inequalities and graphing them is the same step as solving an absolute value equation, which is to isolate the absolute value expression. So we want to take everything that is outside these vertical lines, which is this 3, and move it to the other side. That's what we want to do. So first step is the same. Alright, so we actually have just one thing outside the absolute value, and we just go ahead and do the inverse. Remember, whenever you have a number in front of the absolute value, basically multiplying. So we take 3, the opposite of multiplying by 3 is to divide by 3. Whatever you do to one side, remember, instead of having an equal sign, we have an inequality, but this is where the inequality still cuts the inequality into two sides. So we treat this as the equal sign. Whatever we do to one side, we have to do to the other, so we divide by 3. And so that becomes 1, and we have x minus 7. The absolute value of x minus 7 is greater than or equal to 9 over 3, which is 3. Now here is where step 2 becomes different. Instead of writing two equations, we're going to write a compound inequality and solve for x. So instead of writing two equations, we're going to write a compound inequality, and we're still solving for x. So what do I mean by that? Compound inequality. Well, it's actually, that's the only difference. We're going to take this right here, and what did we say from solving when we took a look at lesson 2.2? We said that this stays the same and this is going to change. So exactly the same for inequalities. We take x minus 7 and we actually just write that once, and this symbol right here is going to go on both sides. And remember, whatever, going all the way back to this setup, whatever is on the left is my smallest value, and whatever is on my right is my largest. So here I have that positive 3, and on the other side, that's where we change the sign and it becomes negative 3. So again, just like at lesson 2.2, when we're solving absolute value equations, this is going to stay the same, but I just have to write that once. And this is where the sign changes. The other side, which is 3 on the right side and negative 3 on the left side. And I'm going to use this inequality on both sides, right here, right there, and right there. Now, again, when you go to step 2, that's when you get rid of these vertical lines. You no longer have them here. Just as similar to the previous lesson. So now we have to solve for x. Well, you might be thrown off by this setup right here, but just focus on the x here. And we need to solve for x. We're subtracting 7. So what is the opposite of subtracting 7? Is to add 7. Not on this time, not just on both sides. We add 7 to all 3 sides. So in the middle, on the right, and on the left. So if we calculate this, negative 3 plus 7, that's 4. Now we have x by itself. We solved for x, and here we have 3 plus 7, which is 10. There we go. This is our answer, our final algebraic answer. So now let's go ahead and graph this on the number line. Now here's where we need to look at our chart. Remember, let's take a look at the symbol here. The symbol that we have, the numbers are both the same. The symbol that we have here is greater than or equal to. Greater than or equal to. Here it is. There's two things we want to point out here. First of all, it says that we're going to use closed circle. So let's go ahead and create our closed circle. So at 4, I have a closed circle. And at 10, I also have a closed circle. Now, the other thing that my chart tells me is where I'm going to shade. Because I have greater than or equal to, I'm going to shade on the outside. That means that on the outside of these points, that's where my solutions are going to be. We're shading on the outside. And there it is. That is my final solution. So you're always going to use this chart when you're graphing your answer. You want to know if you have open or closed circle, or if you're shading on the inside of those points or on the outside of those points. So this table is going to be very helpful. Let's do another example. Alright. Now, a lot of you were thrown off here. What is the very first step we want to do here? We want to isolate the absolute value. But notice here, is there anything outside these vertical lines? Now, a lot of you told me, well, we have 5. But this, remember, treat this as the equal sign. Is there anything on this side where the absolute value is? Is there anything outside of it? No. So basically, is step 1 already done? Did we isolate is the absolute value expression already isolated? Yes. Step 1 is done. That means we go to step 2, which is to write the compound inequality and solve for x. So again, this stays the same. We just have to write that once. And notice we get rid of these vertical lines. We don't need to write that down. We write the symbol, which is less than, on both sides. And this is where we have our sign change. So remember, the positive goes on the right side and the negative goes on the left side. There we go. So we wrote our compound inequality. Now we have to solve for x. So don't forget reverse Pemdas. Don't divide by 2 before first. You don't want to do that. You want to follow reverse Pemdas. So you look if you have addition or subtraction. Here we're adding 3. So we want to look at that first. What is the opposite of adding 3? We subtract 3. Since we're talking about compound inequality, we do it to all 3 sides. -5 minus 3, that's -8. Here, that goes away, so we just have 2x is less than 5 minus 3, which is 2. Alright. Going up the level of reverse Pemdas, here we have multiplication and division. We're multiplying by 2, so the inverse is to divide by 2 on all 3 sides. And so, what we get -8 divided by 2, that's -4. 2 over 2 becomes 1, so we just x. And 2 over 2 is 1. So here is our answer. Now we have to use this to graph it. First thing we want to know, our symbol is less than. So let's go ahead and look at this. Here's less than. So what does it tell us to do? We're going to have open circles. So we're going to have open circles. Let's go ahead and graph those. So at -4, open circle. At 1, open circle. Second thing. So we have open circle, and at this time it tells us to shade on the inside. So we're shading on the inside. So in between those 2 circles, my solution is shaded on the inside. And so here is my final answer right there. Alright. So that is how you graph absolute value inequalities. And that concludes lesson 2.3. Thank you for watching.